Okay, for this lesson, we're going to be working on dividing radicals. So there are specific rules that go with dividing radicals. We're going to start with rationalizing the denominators. You should have done that in a previous class. And then rationalizing the denominator using a conjugate and understand when a radical is simplified. So going back to rationalizing denominators, there are nth root denominators that we're going to work on rationalizing. That will probably be new for you. Okay, so a little bit of review here. Pause the video, work through the bell ringers, and then come back for the solutions. Okay, so remember, if we're looking at something like this, we have to get the same radicals in order to add or subtract things. So square root 54 doesn't work nice, so we got to break it down. Okay, so 2, 27. 27 is 3 times 9. 9 is 3 times 3. So we're looking for pairs of numbers. We got a 3. Those go back under, so it's 3 root 6. Okay, break the 12 down. 2, 6, 2, 3. Pair of 2s, so this is 2 root 3. Break the 108 down. 2, 54, 2, 27. And then again, 27 is 3 3s that we just had a little bit ago. All right, so we have a pair of 2s and a pair of 3s. So remember what happens when you're bringing two things out. Those are going to times. So that would be 2 times 3, which is 6 root 3. That 3 goes back underneath there. 175 breaks down to a 7 and a 25, right? Because how many quarters is $1.75? It's 7 of them. And we break down the 25 to 5 and 5. So we have a pair of 5s. And then we leave that 7 underneath there. So plus 5 root 7. And then we're looking here, 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 and here for things that match. Okay, so the root 3 is the only thing that matches. So then we can just do 2 minus 6, which is a negative 4. And I'm just going to get rid of those like that. And then we have our minus 4 root 3. Okay. So this kind of stretched out answer here is what we got. All right, so for multiplication, for b, we're foiling. We're taking this times this. So we multiply the numbers in front and the numbers underneath. It'll be 12 root 6. And then this times this. So it's 5 is the regular number, so we're just multiplying it by the 3, which is the regular number there. That's 15 root 2. And then we multiply these. So 4 and 4, minus 16 root 3. And then these, so a 4 and a 5 is minus 20. And then again, we look for common radicals, which that's square root 6, square root 2, square root 3. So none of them are common. So you're done after that one step. Okay. So C here, same thing. Probably a little bit easier than B. First, that's 49. Outer, that is 7 root 2. Again, so inner here, that's another 7 root 2. And last, so square root 2 times square root 2 is just a 2, and it's a negative because we got 1 plus and 1 minus. Okay, then you simplify things. Those cancel out in the middle, and then 49 minus 2 is 47. All right, one more review question before we start with the lesson. So we have a square root. We can multiply the stuff underneath. Okay, we're just going from left to right. 3 times 6 is 18. X to the 5th, x to the 4th, that's x to the 9th, and we're still in the square root. We haven't gotten rid of that yet. And now we break this down. So we're pretty much breaking this back down to what we just had. And then we look for the pair of 3s. So those come out. So that's 3 in the front. Put my square root back. The 2 goes back underneath there. And then we're looking at that x to the 9th. How many nice groups of 2 can we get from x to the 9th? Well, we can get 4 nice groups of 2 because that would be x to the 8th. And then how many do we have left over? Just one of those left over. So that is what we get when we simplify. Okay. So first thing we're going over is rationalizing denominators. And this should be review from previous classes. If you have a square root in the bottom, then in order to fix that, you have to multiply it by another square root of that number. Okay? And the reason we're doing that, look how many 5s we have when we multiply by square root 5. We have 2 5s down there now, which simplifies just to a regular 5. And then you have square root 5 on top. Okay? So if you don't like that rationale, then what you do is multiply these. Just multiply everything from left to right, and then ask yourself how to simplify this right here. I can't do anything with the root 5, and square root 25 is a perfect square. So then we have that as the answer. Okay? So square root 8, same thing since it's a square root. So multiply by square root 8, top and bottom. Multiply from left to right. Okay, that x goes in front because that's considered a regular number. It doesn't have a radical. Square root 8 times... I got to cut that out of there. Square root 8 times square root 8 is just an 8. Okay? Now, then you've got to ask yourself, am I completely simplified? So square root 8 right there is not simplified because we can break that down. That's 3 2's. So a square root, you're looking for 2 of a number to bring out, and then that one stays underneath there. So what this turns into right here, that 2 comes out in front of the x, and then that 2 goes back underneath there, and then we have the 8 on the bottom. And again, you got to ask yourself, am I completely simplified? If I didn't have this stuff, would 2 over 8 be simplified? Well, no, we have to simplify between here and here. So that's a 4 down there. So we have x root 2 over 4. All right, a couple more examples here. So C is where the rationalizing gets a little bit more difficult, because if you look at that and you ask yourself, well, if I just multiply by 4 through to 3, top and bottom, that should simplify like before, right? Well, if I multiply from left to right like I just did, that would be 4th root of 9. And is the 4th root of 9 something that's going to work out nice? Well, no, it's not, because I need 4 of a number and I only have 2 of a number. So, back to the drawing board with this stuff. How many more of a number here do I need to simplify the 4th root? That's the question you ask yourself, okay? Well, this is only 1 3. So if I think about how simplifying works, I'm going to have 3 more 3's. Right, so I got 1, 2, 3, 4. So this is what's going to help me figure out the number that I need to multiply by, which 3 times 3 times 3 is 27. So that's the number we're going to have to multiply in a 4th root. Okay, and the reason being is because we have to have 4 of a number here to simplify this out. So here's 1, 2, 3, 4. 4 of the 3's to simplify this. And so the bottom, I don't need to worry about what 3 times 27 is. I just know that this will be a 3 when I'm done, because it's the 4th root of, it'll be 81 if I multiply it, but I know that there's 4 3's if I were to factor tree it anyways. Okay, so I have a 7 and then a 4th root 27 on top. Okay, and I don't need to simplify the 27 on top again, because remember 27 is only 3 3's. I need 4 of a number to simplify. All right, so D, we're back to a square root. Square roots are a lot nicer because it's really quick. You just multiply by the same square root in the bottom. So square root A. And again, we're doing that because square roots need 2 of a number. I have 2 A's, and that would simplify to just an A after I multiply those out. Okay, and so the idea with this one is I have a square root 5 and a square root A. We have to remember how to multiply 2 square roots, multiply the stuff underneath. So it'll be square root 5A on top. Okay, and your brain might want to do this because we've done stuff like that in the past, but you can't because one's under the radical and one is not. Okay, so that's why you can't simplify that like that. Okay. So let's try a few more of these. Okay, so if you want to give these a try, pause the video and then get started. If you just want to follow along, then keep playing the video. Okay, so for A, we have square root 2x under the radical. So both of these are under the radical. So that means we're going to have to multiply by square root 2x, right? Because it's just a square root. We multiply by the same square roots if it's just a regular root, okay? So then this would get me 2x in the bottom, and I'd have 11 root 2x on top. And then you're done there. Okay? So for b, remember you have the option of putting this back together under one radical, but everything's different here. So I would leave it, and you're going to rationalize here. So how many more b's do we need for this to fix itself? There's only one. So we need 2 more b's down here since this is just b to the first. So 2 more b's would be b squared. Okay? I think that simplifying the variables is a little bit nicer than simplifying the numbers, just because it's like we got one of these, we only need 2 more of those to get us to b to the third. And then since we got this on the bottom, right, well, what's cube root of b to the third? That's just b. And then we multiply on the top. So 16a to the fourth b squared, all under a cube root. And we do have to double check to see if the top is simplified or not, okay? So we leave the bottom. We know that's simplified. The top, the 16, we can break that down. So I'll put that over here. 2 and 8. 16 is 3 2's. Okay? So we got to bring a 2 out. And then cube root of 2 back underneath there. And now we're looking at the a's. How many nice groups of 3 can we get from the a's? That's just one of them. And that would take 3 of those, leaving 1 back underneath there. And then the b squared is still in the radical and b on the bottom. Okay? So I like to rationalize first. That's my cube root b squared part. And then simplify in the end. That's the way I think is easiest in your brain. Okay? So c, square root 5 over square root 7. Now this looks a little bit different than what we've done before. But remember our quotient properties? We can write this like this. And then it looks exactly the same as what we've been doing. Same thing over here. So cube root 5 over cube root 3b. Then you just rationalize after you split it up, okay? So square root 7, we just need another square root 7 to simplify that out. So 5 times root 7 is root 35 on top. And on the bottom, square root 7 times square root 7 is simply just a 7. Okay? And then for d, okay, so we split it using our quotient property. And then over here, we ask ourselves, how many more 3's we need? Well, we need 2 3's, right? Because there's 1 here, and we have to get to 3 of them. So 1, 2, 3, that's a 9. And then we need 2 more b's, so b squared. So 9b squared is my rationalizing radical. Okay? And then we just multiply those from left to right. So on the top, we'll have 45 b squared, and that's under a cube root. And on the bottom, we used our 3's to rationalize, so there's 3 3's, right? 1, 2, 3. So that means it'll just be a regular 3. And then we have 3 b's, which would just be a regular b. Okay? So that one's not bad if we understand the this part here where we just need to multiply it by something to fix the radical. Okay? So, a couple more here for rationalizing, and then we'll look at using conjugates. So, with this one, if you need to split it to help you out a little bit, you can. Otherwise, you can just leave it. Okay? And we know we're going to rationalize it anyways. So, cube root, how many more 2's do we need? There's only 1 there. That means we need 2 more. So there's 1, there's 2. What number does that give us? 4. Okay? We got 2 y's there. How many more do we need? Well, we need 3 of a number, so we just need 1 more y. So 4y is my rationalizing number. Okay? So then we just go from left to right. So on the top, we have cube root 4xy. On the bottom, we have our 3 2's in a cube root, so that's a regular 2. And we have our 3 y's in a cube root, so that's a regular y. And done. For b So sometimes you look to see if you can simplify this stuff first. Well, 32 is even, 3 is odd, so we can't really do anything. So we have to rationalize right away. So you gotta ask yourself, so how many more of a number do we need? And now this is a fourth root, so we need 4 of a number. So we need 4 3s. There's 1 there, we need 3 more. Okay, so you're gonna need 27. 27 is the magic number to get us all the 3's that we need. All right, and then how many more z's do we need? Well, we have 2 of them there, so that means we need 2 more. Okay, so we're multiplying by fourth root 27z squared. So in the bottom, that's the easy part, we got our 4 3's, so that's just 3z because we had 4 of each of those. And in the numerator, we have 864, and then we just go from left to the right. So x to the 9th, y to the 6th, z squared in the fourth root. And now obviously, that one, we're probably going to have to simplify. Okay? So what I would probably do is the trick that I taught you in a previous lesson. We know that 864 is 32 and 27 because that's how we got there. And our 27 came from here, which is our 3 3's. So I probably would have just left these 3 3's here and then broke down my 32. So 2, 16, 2, 8, and then the 8 is 2, 2, 2. Okay? Then we're looking for 4 of a number. So let's take these 4 2's, and then these 4 other numbers go back. Okay, so these 4 2's gives us a 2 in front. So 2, and then we'll have a fourth root. We've got to figure out what's going back underneath. So this is 27 times 2 is 54. And now we go from left to the right with the variables. So how many nice groups of 4 can we get from x to the 9th? 2 of them, and that would take 8, leaving 1 left. How many nice groups from the 6? From the y to the 6, excuse me. Only 1, and that would leave 2 left. And then we can't take any of the z's because there's not enough. Oops. Let's fix that. So the z squared stays there. And then in the bottom, we just had that 3z. Okay? So that one is pretty hard because we have that large number here in the end. But the concept is the same. I need 4 of something to fix that. Okay? So next concept would be multiplying using conjugates and rationalizing using conjugates. So what a conjugate is, let's say we have something like this, 9 plus root 2. Its conjugate is 9 minus root 2. So it's pretty much you keep the same exact numbers, you change the plus to a minus. Okay? So same thing here, I got a negative here. I change the middle number or middle operator to the opposite. So minus goes to plus, plus goes to minus, minus goes to plus. All right? Nothing else changes. You're just switching that sign in the middle. So we have to use that on questions like this. So you might be thinking, hey, we can just multiply this 1 by a root 3 and multiply that by a root 3. We can't because, remember, every time I've taught something with multiplication, whenever you have a plus or a minus in there, you have to be careful with that. Okay, you can't just multiply a single part of a question by a number when you have a plus another number. Okay, so we have to multiply this by what's called the conjugate. Okay, so multiply this by 4 minus root 3. And if I'm doing it on the bottom, I have to do it on the top. Okay, because if you look from the denominator to the numerator, 4 minus root 3 over 4 minus root 3 is a fancy 1. It's called the clever 1. Okay. From there, once you remember that, you're just foiling things out and distributing. So the 13 goes to there. Okay, so we got 13 times 4, that is 52, minus 13 root 3. That's the numerator, not bad, just taking the 13 through. And then we got to remember how to FOIL a radical. So first is 16, outer, minus 4 root 3, inner, same, so that's a root 3 and a 4, so plus 4 root 3. And then minus 3, because square root 3 times square root 3 is just a 3. Okay? So what's the point of using the conjugate? So here's where you should see the point of using the conjugate. So what happens with this stuff right here? Well, that is going to cancel out because they're opposites. Okay, then on the bottom you just have 16 minus 3, which is a nice number. So we have on the top 15 minus 13 root 3, and in the denominator we have a 13. Okay, so 16 minus 3 is 13. So by using conjugates, we have simplified the radical in the denominator. So what you should do in the end, though, is we look at this number, we look at the numbers in front of the radical and the regular numbers, and you see if you can simplify those. So you have to take a number out of all of those, which we can. 13 comes out of 52. It's 4 times, like we had in the beginning, 13 times 4. So this simplifies down to 4 minus root 3. So for B, we're going to do something similar. All right, so we have this on the bottom, so we're going to have to do the conjugate of that. So square root 5 plus square root 2. All right, so conjugates are just the same numbers, different operator in the middle. And we have to do the same thing on the top. Okay, so in the numerator, we're going to distribute this. So that would be, we'll write it down here, 6 root 5 plus 6 root 2. And denominator, we're going to FOIL it out. So square root, well, that actually will cancel out to just a 5, or square root 25. So it'll be 5 plus root 10 minus root 10 minus root 4, which is just a 2, so minus 2. So those cancel on the bottom. And then we're going to have a 5 minus a 2. So we'll rewrite this again. So we have 6 root 5 plus, make sure we fix that 5, 6 root 5 plus 6 root 2 over 5 minus 2 is 3. Now we got to look at this. We can take a 3 from each of those, okay? So we'll take a 3 out of each of those. That's going to get rid of that and turn these both into 2s. So we have a 2 root 5 plus 2 root 2. And then that's our answer for that one. Okay? So a couple more of these here. So FOIL by the conjugate. So what's the conjugate of 3 minus root 2? Well, it's going to be 3 plus root 2 on top and bottom. Okay? So we have 7 times 3 is 21. 7 root 2, and then 3 root 2, and then root 2 times root 2 is just a 2, or square root 4. We want that as a 2, though. Okay, so that's my numerator right there. I haven't fixed the bottom yet. Okay, so let's fix that one. And then we can do the bottom. So 21, So 21 plus 2, that and that is a 23. 7 root 2 plus 3 root 2 is a 10 root 2. And then the bottom, okay, 3 times 3 is 9. So plus 3 root 2 minus 3 root 2. Negative root 2 times positive root 2 is just a negative 2, right? Because that's a square root 4 again. Those are going to cancel. So the bottom, we just have a 9 minus 2, which is 7. So we have 23 plus 10 root 2 over 7. And again, look here, here, and here before you call it quits to see if you can take anything out. And we can't, since 7 is prime and does not go into the 23 or the 10. Okay, one more of these ones. So 4 plus root 3, 4 plus root 3. And why are we doing 4 plus root 3 again? Because we are using conjugates. Okay, so I'll do the top, simplify that just like the last one. So 8 plus 2 root 3 plus 4 root 3, and then square root 3 times square root 3 is just a 3. And maybe this time I'll multiply out the bottom here as well, just to kind of save a little bit of space with work. So 4 times 4, 16. Plus 4 root 3 minus 4 root 3 minus 3. Those are going to cancel. That's the point of the conjugates. And in the top, we have 8 plus 3, which is 11. 2 plus 4 here and here, plus 6 root 3 over 16 minus 3 is a 13. And we are done with that. Okay? So that's multiplying using the conjugates. So you just change the sign in the middle. So the final thing here, how do I know when a radical is simplified? So here's some things to think about. We have no perfect powers factors of the radicand, so that would be something like this. We don't have any of that going on because that's not simplified. Cube root of x cubed is just an x, right? You have to make sure you've simplified variables completely. No radicand contains a fraction. That means we can't have a fraction underneath a radical, like this one down here. There's a fraction in there, okay? And no denominator contains a radical. So that's the same thing. You can't have something like this, all right? So we've kind of covered all of these topics. I'm just going to remind you one more time of how to determine if things are simplified or not, and then we will be done. Okay, so looking at this one, 48 there are some perfect squares in there. So what you do is you factor tree it, right? We've done this already. So 2, 24, 2, 12, 2, 6, 2, 3. So we see perfect squares in there because I see 2 of a number there, 2 of a number there. Those are both what are perfect squares. So we're breaking both of those out. So we get a 2 from this one and a 2 from this one, which would give us a 4 in the front. Okay? And then we have that 3 back underneath there. And then same thing with x to the 5th. You ask yourself, how many nice groups of 2 can I get from x to the 5th? Well, I can get 2 nice groups because that's x to the 4th, right? So I have one of those left. So that goes back under. Okay? So this one, we want to use our quotient property. So square root 1 over square root 2. So we know that this simplifies, this does not. All right? So which you could, if you wanted to, simplify it to 1 over root 2. But then you have to simplify it using rationalizing, because we have a square root 2 in the bottom. So remember, square roots are easy. Just multiply it by another square root. Those are the ones that just simplify themselves pretty quick. So you get square root 2 over 2. Okay? So same thing here. We kind of made the last one look like this. So square root in the bottom. Square roots are easy. Just multiply it by another square root and simplify it as much as you can. So the bottom just turned into a 6. Top, square root 6. Okay? So this is using all of the rules that we learned to simplify stuff, and we have to double check if things are completely simplified. Okay? So this last slide was just a reminder of all the things to look for to determine if something is completely simplified. So we learned how to rationalize using square roots. We learned cube roots. We learned conjugates as well. So hopefully everything works out. Good luck on your homework. Please leave me a like and subscribe if you enjoyed the video.